Put it in your bio. I didn't take the first year of the class. I'm in strategic, which should be DECA, but I'm not. I never even took the first year of the class.
I'm chapter president, so just see them.
We never see you. You're not.
Because I'm not in the class. But
So
I'm still
therefore,
the
you're not the president.
Yes, I am.
You can't be the president if you don't live in the country.
But no, but here's the thing. I am. So.
Nope.
All right, can we table this for another time?
No, it's still outrageous. Serious situation.
All right, so you all know we got a test today. I had mentioned that the first chunk of today, at most the first half of class, we're going to take some time to do some last-minute review, right? Iron out some last-minute kinks. Let me know, like, hey, Mr. Reed, this still doesn't make sense. We'll brush up. I'm going to be at your disposal to help you review and whatever. But then the last half, I'm going to give the test. It's 20 questions this time, and so it should be a little. Last time I think was 30. I had a lot of like concept questions. This one is about the same. I have a handful of conceptual questions, like true, false, whatever, and then the last half is solve like. I never know what to call them.
Okay.
Like workout problems, or I think I called them like calculated problems. Like you got to do some math, do some physics, equations, typical stuff.
Okay, so the last quiz had 30. That's one has 20. So does that mean the next one's going to have 10 and the next one is not even going to exist?
Incorrect. No.
No, you just have to make
Yeah.
So what I'm hearing is this.
What?
I said, so what I'm hearing is this thing.
Yes, you will be able to use your calculator.
And
Yes. You will be able to use your pencil, your brain, your equation sheet, and then the calculator.
You made
Right?
the announcement that you use a calculator this time.
Yes, I apologize. I felt bad. I don't know who asked me or something. Someone brought it to attention like middle of the test. Like, how are we supposed to do this? I was like, use your calculator. They're like, oh, we can use it. In my head, I just assumed, like, yeah, you got to get your calculator to do the math, right? And I never actually told you.
Calculators allowed, and it never
Yeah, I never really, like, formally approved them for you guys. So, yeah, I apologize.
Well, because
Junior head, good luck.
Because generally, if a teacher doesn't say you can have a calculator, you don't just pull it out.
Good. I appreciate that.
My students think that if they're done with their test, they can just go back to their seat and whip out their phone.
Because that's when they're
It's like, what do you think you're doing?
Yeah. So I appreciate that. Again, apologize retroactively for not formally telling you guys you can use your test or your calculator. Okay, bring it back. This time, how do you want me to help you study and review? What do you want me to go over? Did you guys see my message about the multiple choice question, the answer keys?
Yes.
Did you guys see?
I was on group class.
I spent a lot of time on that, so I really hope you guys at least used it and
See, by the time
got something from
by
it.
the time I saw it, it was a little bit late. I didn't see it till this morning.
I sent it out. I don't know when I sent it out. I did it as soon as I could. Wasn't it? Yeah, it was a while ago, so I wasn't.
What are you? Are you just really constipated or what?
I lost spicy stuff for lunch.
All right, let's table that conversation. How did I? Oh, that's engineering. That's why. Did I put it as? Yeah, these answer keys. So hopefully you guys saw these. I went and solved that multiple choice A, multiple choice B, like by hand, did the work for you, rather than just here's the answer. So I really hope you guys got value out of that. It did take me a long time to solve them all, scan them, upload them, compile them, blah, blah, blah. Multiple choice question B, we didn't get a chance to talk about, so I guess I'll start with that. Did anybody do multiple choice MCQ, the second one on AP Classroom? Because I can go through and solve some of those.
If you want some more explanation on like, wait, how do you do that?
No, sorry.
Yeah, if you did it, I want to take time now to go over some of those. We'll do that, and then I want to turn it loose to like, hey, how do you want me to help you? What are you still struggling with? I need you guys to be giving me feedback on, hey, what do you need help with?
I keep seeing your water bottle in the corner of my eye, and I think it's whipped cream can.
We go over
Which one?
11.
On B?
Yeah.
Yes, I think that's in the first part.
It is. I was looking at it. It kind of makes sense.
Okay. I don't know where it is. Oh, there. All right. So this question, a car travels with a tangential speed around a radius r. It's turning to the left, shows the car from the rear view, right? That's what's happening. That car is turning to the left, right? A force diagram on the car when it's going 5 meters per second is shown in figure 2. Those are the forces on the car if it's turning and has a velocity of 5 meters per second. So I went up to the picture and I labeled it. That's what I do. All right, I put notes and label things as best I can. Force diagram when the car is at an unknown speed for the same curve is in figure 3. That's this guy. Huge friction force. That's the main difference. It asks, what is the velocity in this situation? Right? So you're given some knowns. Just so that it shows up a little better. Right? So what I did is I said, okay, this situation, I know everything. I know centripetal force is being caused by what force? If I'm turning, what force is actually giving me the centripetal force to turn? Friction. The friction force of your tires is what allows you to actually turn. That is your FC. So I said, okay, my friction force is FC. It gave me the velocity. M and R are just variables at this point. So this equation represents situation 1 that was given. I was given situation 2 where I say, okay, I'm turning, I still got a friction force, but it's 9 times the original. So I have 9 times the friction of this scenario. My velocity is unknown, but I know it's centripetal motion, so it's m v squared over r. So what I do is I'm basically going to simplify this and solve. Well, you find out, how do I calculate the friction force? Well, I just plug it in from my first equation. The original friction is this. If I have 9 times that original, I have 9 times that equation. Does that make sense? That's just easy substitution. Then I got to do some algebra. I got to clean this up. Well, I got a radius on both sides. I got a mass on both sides. That's just 9 times 5 times 5. Do that math. And then it's equal to v squared. I'm done. Just take the square root of both sides. Tells me, hey, the velocity in this situation is 15 meters per second. So then I got to come down my answers. Yep, 15. That's the answer that I choose. Does that help? Basically, the key to this problem is write the equation for the known scenario and use it to help you solve the unknown scenario. Basically, plug in friction force and solve. Still using Newton's second law. Still doing F equals ma. You still have to know, okay, a car's turning.
I need a force towards the center of that turn. Well, what force acts in that direction? Normal force and gravity are in a completely different direction, so that's not it. Well, the only other force on the car is friction of the tires. That is my centripetal force. F equals ma. It's centripetal acceleration. It's not just A, it's AC. I know an equation for that. V squared over R. Right, there I got it. Do the same thing again. Substitute, and it's just algebra from there. Does that make a little more sense? I feel good? Right? What happens if I wanted to write, just off cuff a little bit, forget what part of the screen is visible. Okay, over here. What happens if I want to write AC, centripetal acceleration? What's that equal to? V squared over R. This is linear velocity, right? It's what we're used to. We're comfortable with that. Is there another way to write centripetal acceleration?
M1, M2 over R3.
No, that could be. That's the universal gravitation, right? He's talking about F gravity is capital G, M1, M2 over R squared. That's the force of gravity between any two objects. This, I'm just looking at centripetal acceleration. Do you remember how when you have circular motion, you could have linear speeds that cause circular motion, but you also have angular, right? How fast am I spinning? Do you remember the variable for how fast you rotate? The weird Greek letter.
It's like a U.
Kind, almost.
What's it called?
It's more like a double U.
Is it a W?
It looks like a W, but it's actually the Greek letter omega. Remember omega?
No, we do remember.
Oh, nothing. Yeah, okay.
Yeah.
I was thinking of the wrong thing.
Oh yeah.
No.
But I need to. These need to be equal. The linear velocity is equal to omega r. But I'm squaring it, so I got to square the whole thing. Well, I can simplify that.
See, that just kind of flew on my notes. See, I was like, I think I was catching up when I was writing stuff down.
Oh, like this
And
equation?
so I wrote RW squared, but when in actuality that's actually omega.
Oh, that's fine.
Because I
Yeah.
didn't know what W stood for the other day when I was.
Okay. Yep. It looks like a W, but it's technically omega, and it's the angular velocity. It's not linear velocity. It's not meters per second. It's angular velocity. It could be rotations per second, RPM, rotations per minute. But in science and physics, it's normally radians per second. If I plug in meters, I get radians per second. So you want to always default to omega is in radians per second. But I want to show you these are the same thing. These are both centripetal acceleration. Because one of the problems I could say, hey, your car is traveling at 10 radians per second. You're like, oh crap, where do I put that in? How do I plug that in? We're like, wait, radians per second, that's angular. I need to change my variables. I'm going to use this equation, plug it in, solve it. So I want you to be aware that when you have circular motion, you do have a linear speed, how fast you're going around the turn, but you're also in a circle. So you also have a measure of circular motion. Easy way to remember it is if you know this, you should know that. I'm almost positive that's on your equation sheet. Just remember the velocity, V equals R omega. And then you could plug in and solve for this yourself. All right. What's another one that I can do on the MCQ 2. Or B, rather. Any other ones you want me to work through?
Are there any on here with gravitation?
Oh, yeah. Oh, yeah.
Wow.
So the universal gravitation equation, like G m1 m2 over r squared,
Yeah.
that one.
So we can use the equation sheet, right?
Yep, you can always use your AP equation sheet. Yep. So especially when we get to actually take the AP test, you want to have used this enough that you're familiar with it. Right? You know where stuff is, you know what's on there and what's not. Or you know how to maybe take two of the equations on your sheet and combine them to solve for a new equation. Yeah, you'll always be able to use that. So this question was a pretty good one. This has 3 different objects. And it's saying 3 planets are along in the same line. The gravitational force on planet X from planet Z is F naught. So I did that up here. I said, okay, the force on X from Z is called F naught. Well, I can calculate that, right? The force that this planet exerts on this planet, I'll use universal gravitation. G m naught times 9m naught divided by 3r squared. You see that? I want to know the gravitational force between these two things. Well, any two objects, I can calculate the gravitational force with universal gravitation. Is that one on your equation sheet? Should be. Yeah. It's technically on the back. No, technically it's the back. In your equations, it's right in the middle, at the near the very bottom. You guys all see it? Alright, I'd recommend you get that equation out so that you know where it is on this test. Do you guys see it? Can I that was a question to you guys.
Yeah, I
Do
see
you
it.
see this equation?
I see it.
You find it?
I see it.
Alright? So that way you know when you need to use it on the test, you know where it's at. And then you just plug it in. Mass 1 is m naught. Mass 2 is 9m naught divided by 3r squared. Now I forgot to put parentheses. It's not 3r squared, it's 3r squared. So this actually is 9r squared. You're like, okay, that's something. It continues and says, what is the net force on planet Y? So you have to realize, wait, there's 2 objects that are surrounding planet Y. I have 2 gravitational forces acting on this. So, right, Fy, the force on planet Y from this planet, 4m naught is planet mass 1, 9m naught is mass 2. What's the distance between the 2 planets? Well, it's 2r naught. If I do that math, I get 9 times g mo ro squared. Well, I forgot to simplify, but the original, the force on this planet from Z, if I do this math, 3 times 3 is 9, so the 9's go away. So that original force is right here. I can plug it in. It's 9 FO. So on this guy, This force is 9 FO, or F naught. Now I need to see, well, what's the force that this planet exerts on Y? Well, 4 MO, MO, the two masses. What's the distance between the two planets? RO. If I simplify it, pull my coefficients out, 4 times GMO-MO-RO, that was the original force. So I'm going to write it as FO. What direction on planet Y, which direction does this force act? This way. Brody said this planet pulls this force towards it. So this, that's what I did here, that force is 4 times FO. This planet, what direction is that force acting on this object? This object has mass and it's attracting it. So this force was 9 MFO. So I have to do a free body diagram and say, wait a minute, I have two opposite forces. Well, what's the total force? Well, I just take 9 minus 4 and get 5. That's my answer. 5 times the original force to the right. So I just used universal gravitation twice, well technically 3 times, but it's just plug and chug, and then algebra. Big thing is, do you understand that there's 3 objects? If I look at the forces on this object, this has mass, so it exerts gravity. This has mass, so it also exerts gravity. Here's a question that'll be really useful for the test. Can gravity ever push something away?
No.
No. Right? Gravity always is Gravity is everything with mass is attracted to everything else with mass. They're always attracted to each other. This planet can't push another planet away with its gravity. It's literally the opposite of what gravity is. Take note of that. You might use that in about 20 minutes. Any other questions? What else can I help with?
This is technically on the content question, but
Okay.
if I were to write on this, would that be able to keep me from using it?
Yes.
Okay.
Yes, that would disqualify you from using it. And I say that because, one, that's like everyone needs an equal playing field. You don't get to make whatever notes you want on your equation sheet. 2, AP test, there's no way they're going to let you jot some notes down before you take it. Right? So we also need to have an environment where we prepare for what we're going to experience in the AP test, which is they're going to hand you it like right before you take the test and let you go. Now, if you're in the middle of a test, well, you might be able to write on that after you start the test.
Because there's
Wait,
a lot
right
of
on the paper?
Potentially. Don't quote me on that.
Yeah, I think you could.
You should be able
I mean,
to.
Yeah,
once
they-
test starts.
The only thing is,
You can't. I know
Right.
They don't let you take any paper.
Correct.
Because you this way don't write. anything
Yeah, you'll
down.
have nothing and they'll give you all the papers, but after that,
I think
unless they specify, they might have a rule like all extra materials can't be written on, only like your test booklet. That could be a rule that they have, but it might be that you could write on it. So,
Because like I know like when you take like other tests like for the SAT, you can like mark up the book as much as you want.
okay.
Whatever
That
you
sounds
put on-
right.
Whatever you put on it doesn't matter if you actually have.
You got to know it.
They only care about what you put in for your
Correct.
answer.
Yeah, your
So I
answer
don't think-
booklet's the only thing scored.
I don't think it matters if you draw anything on there.
Yeah. But I just don't want you to quote me on it because I actually don't know what AP's rules are. I do know you can't write on your equation sheet.
It's just on this paper. There's like a lot of formulas,
Uh-huh.
so I was like trying to think of a way I could like label them just so I could keep track of which one's which.
Okay.
Like I guess I wouldn't have to write that directly on the paper. I could put like numbers next to it, then like on a separate sheet of paper.
Yep.
I don't have out during the test with which one's which.
Yeah, you could do that. Yep. Yep.
I just want to make sure I remember which one.
Yeah, because that's part of the challenge. You have a huge list of equations. They're at your disposal, but the thing is you still got to know how to use them. That's why they give you equations, because you still have to demonstrate you know how to use it. All right? Other questions? How can I help you right now? What are we still not sure about? I need feedback from you guys right now. Because if we sit here in silence, we'll just go take tests right now.
Have you thought about AP t-shirts?
AP t-shirts? Is that what you said?
Yeah,
Fine,
like,
easy.
there are like a couple of classes. I don't know what dictates whether you get them or not, but like,
What are your teachers?
some of the AP
Never heard of
classes,
It's just the teachers that order them.
we
Because
just design a
Augustine
t-shirt
will,
and then
speaking
we
of
order
this
them.
I
stuff.
think Speakley's the only one that does that. Isn't he?
No, Augustine's done it before.
Oh, he has.
Yeah,
Okay. He just didn't do it last year.
we're doing it for Spanish. But
We almost did one for
no one cares.
AP Lang, I think.
Can we do
Oh yeah,
one?
we were
Big
gonna
picture.
say
The
shift happens, but
Shifts happen at the butt.
yeah.
I
Which
don't
one?
remember what it is.
Was it on one of these?
No, it was like like the big picture stuff.
Oh, the big ideas.
That.
Yes, yes, yes.
I almost wore mine.
Oh,
Maybe.
shit.
Okay, I know what you're saying.
Shift happens, but
No.
I wish we could have had that on our alien.
And you had to quote from you on the back.
Yeah, okay.
It's on a
So
website.
Maggie was saying the big ideas. Remember that document I had on I put on AP Classroom? It's like a condensed summary of all of the big things that we need to know each unit. Right? The big ideas, the big concepts.
I mean, I forgot
That's a
about
good
it till
idea.
now, but
Well,
I remember.
I want you guys to be reading that a lot, right? Even in the middle of a unit, you could ask yourself, like, crap, like, what's the point of all this? Like, what is Mr. H talking about? What am I really supposed to be getting out of this? This document can help guide you. Like, oh, we talked about this. So if you go to Classroom, everyone's got it there. If you go to Classroom, I think I have it down in the general info. So AP Physics 1, big ideas.
So it's on the stream.
I always go to classwork. I don't like the stream. It doesn't make sense to me.
I found the big ideas.
So in here, this is literally all the key concepts, unit by unit.
Who was it? Williamson who hates the stream?
Yes, Williamson hated the stream.
Yeah, I can't stand it.
I don't mind it. It's
I get it, but it's just, to me, I organize the classwork unit by unit. That makes a lot more sense
The
to
only
me.
thing that I find nice about it is that, like, if it's on the stream, it will, like, tell you when it's due and, like, I don't know. I feel like it will show, like, how
Classwork does it
it
too.
will show, like, how recent it's been added. So, like, if you like
Fair.
look for something recent, you just look for the recent thing, not have to go dig through.
Well, my classwork does that, but it just goes backwards. The things at the top are what were just added. Or if you open up Unit 3, the things at the top were most recent. But anyway, let's. Okay, I want to go through some of these big ideas.
You see, the stream works the same way my folder does. I keep all my papers in one folder. Now everything's there. You just gotta find it.
Okay, big ideas. Do you have any questions of these? Something in a circular motion has a force pulling it where?
To the center.
To the center. Centripetal. Center seeking. Circular motion. It should make a lot of sense, right? If I'm driving my car, my velocity is pointed this way. If I turn, isn't my velocity turning?
Yes, sir.
How can I change the direction of my motion? Something has to push me or pull me, but something has to keep turning me constantly. Well, it just so happens that to turn to the left, that's pointed directly to the center of my turn. That's why the force always points to the center. It's always going to the left. That's also why I can be going at a constant speed. Am I accelerating if my speed is constant?
No,
If I'm going 50 mile an hour,
run the same.
Yeah, there is no acceleration. So what does that mean about my net force?
Yes.
What does that tell me about my net force if my velocity is constant?
0.
It's 0. No acceleration, no force. That's Newton's second law. However, what if I'm going 50 mile an hour in a turn? Key question. Think about this. Is my velocity changing 50 mile an hour in a turn? Is my velocity, not speed, my velocity, is that changing?
Which velocity?
My car's velocity.
But you're-
I'm on cruise 50 mile an hour in a turn. Think about what a velocity is.
Because your tangential velocity is staying the same.
Correct. I'm still at 50 mile an hour.
Your angular
That's just a speed, though.
Speed in any direction.
Josh just said velocity is a speed and a direction. If I'm going 50 miles an hour in a turn,
Your velocity does change.
I am changing velocity.
Your speed
Good.
is staying the same, but your direction is changing, and therefore your velocity changes.
Exactly. So if my velocity is changing, am I accelerating?
It's just like we were talking
Yes.
about in that lab we did outside with like throwing it in different degrees.
Yep.
Like you could throw it up in the same direction that you throw it forward.
Correct. Yes.
Okay.
So we've determined it's the same speed, but wait, it's turning. There is acceleration. You guys know the acceleration causing a turn is centripetal acceleration. So then you just like, well, F equals ma. I got centripetal acceleration. What's my centripetal force? What force acts on a level ground in a turn? Think of a car. What force causes the centripetal force? Friction. A centripetal force isn't a thing. Like you can't do a centripetal force. You have to use another force to cause centripetal motion. Centripetal force is a general class of how the force is being applied. It just means the force is always pointed to the center of your turn. Right? So that's really key. Velocity is a magnitude and a direction. Even though my speed's the same, I am still accelerating because my velocity is changing. If I have a change in velocity, I have an acceleration. Newton's second law tells me if I have any acceleration, there has to be some force acting. And then you can do your free body diagram and see, well, like crap. Gravity is pointing down, normal force is pointing up. None of those forces are in the direction of my turn. Oh, friction. I got to add friction to my free body diagram. That is my that's what I plug into F equals ma. What's the equation for centripetal acceleration? V squared over r. I'm not sure if that... Oh, that is on here. That's on here. Top left of your equation sheet, AC is V squared over R. So you got that. You should know it. Should be easy, but it's there. You'd also want to remember velocity is omega R. You could plug that in and find, well, what's acceleration, centripetal acceleration in angular components? Good. Okay, centrifugal, fake force. It's not real. It's only Newton's third law. It's a reaction. They are the reaction to a centripetal force. If my car is shoving my car to the left to make the turn, my body has inertia. I want to keep going. The car has to turn and hit me and apply a force. That's why I feel like I'm going this way, because something is pushing me to the center. Right? Your inertia keeps you going until something actually forces you to make the turn as well. Okay?
Level turn, we talked about this. Friction's the only force causing you to make the circle. Gravity and normal force are the other force acting. They're in a completely different direction. They're irrelevant to circular motion. Banked turn. If you have an angled turn, my normal force is going like this. Well, part of that is towards the center of my circle. So I got to do a free body diagram and see what part of the normal force points in to see what part actually lets me make that turn. My friction is along the road, so I got to have another part that points in. Conical pendulum, right? You have something rotating like this. It's a pendulum, back and forth, but in a cone, a rotation. What force allows it to stay in a circular rotation? Tension force, right? There's gravity pulling straight down. Some part of that gravity is along the string. Well, the string pulls back, keeps it tight. That force is constantly pulling it in. So that's a weird one. They make a weird emphasis on conical pendulums, which is just something swinging in a circle. Centripetal acceleration is v squared over r. You guys should know this. It's on your equation sheet. Newton's second law, F equals ma. Just plug in what centripetal acceleration is, because I got an equation for it. And just know the force causing centripetal acceleration is your centripetal force. Vertical loop. It's another one you'll want to take note of in the next 10 minutes. Centripetal acceleration at the top, it has to be equal or greater than gravity. If it's not, gravity is going to take over and not keep you in a circular path, but it's going to shove you to the ground. You need to be going fast enough so that gravity doesn't pull you down, gravity just keeps you in a circle. Right? Makes sense. If I go too slow, I don't need a lot of centripetal motion or force. So at the very top, gravity is going to be like, oh, I'll give you some to keep you in a circle, but oh, by the way, I got extra force left over. I'm going to shove you to the ground. So you have to be going fast enough so that the centripetal acceleration is 9.8 or more. What allows you to have more force than just gravity? You're going 100 miles an hour through this loop-de-loop. Gravity can't provide enough force to keep you in that circle. What's the other force that keeps you in a loop? What else pushes you down at the top of that loop? No, you're in a roller coaster. You're just sitting in a cart. The normal force, right? You're sitting on a seat, but you're upside down. So now the seat is above you, and it's shoving you down. You're going so fast that, right, it feels like you're getting shoved into the seat. Well, the seat pushes you back, keeps you in a circle. Kinematic equations. We didn't do a ton of this. All our motion equations for linear motion, same thing, but in a circle. You just replace velocity with angular velocity. Replace position with angular position. Right? Universal gravitation. This is on your equation sheet, but we got to know.
0.67 times 10 to the negative what?
Yep, and that constant, G, that number is given. It's on your equation sheet. I think it's on the back side. It's a constant number given. You just type that number in and calculate.
There it is, universal gravitation.
Gravity is anything with mass attracts anything else with mass. Gravity fields, right? You remember the curvature? That example of you put the earth on like a sheet and it bows it down. Anytime you get close to the earth, it's steeper. It'll suck you in more. Gravity does the same thing. The closer you get, the stronger you get. you can use what's called a gravitational field, right? Gravity, I'm attracting everything to me. That spreads out infinitely. Gets really weak really fast. But there's this field around me where I'm pulling everything towards me. I got to get really close to actually feel that force be strong enough to actually pull me in. Otherwise, it's so small I don't notice it. But at any point in that field, you can calculate gravitational force. And at that point, you could draw a vector and say, hey, at this distance away, the force is this strong. The vector is that big. If I get closer, my force gets stronger, so my vector gets bigger. What direction are the vectors pointed at any point in space? You got the sun. You look at this field, at any point you calculate the strength of the gravitational force. What direction is that force pointed? Here's my Earth, here's the sun. Gravity is pulling on the Earth, isn't it? Where's that force pointed? Is it pointed up? Is it pointed this way? Is gravity pushing the Earth?
Moving.
This is my Earth.
That's the Earth.
This is the sun.
That's the sun.
Gravity is pulling the Earth of the sun. Where is it pointed? Is it pushing the sun away? Is it pushing, or the Earth? Is it pushing the Earth up?
She's got a question.
The sun.
What the sun is pushing in direction.
The sun has gravity.
It was the sun's gravity. The sun's
How is that gravitational force acting on the Earth? It's not pushing the Earth away.
Pulling it in.
It's pulling it in. So the force is pointing directly towards the center of the sun. Any point in space, the force of gravity of that object points directly back towards it. Right? That's why we stay in orbit. The sun is constantly pulling us towards itself. So it keeps us in a circle. But this is that concept of a gravitational field. It's basically you just pick a point in outer space and look at how strong the sun's gravity is on that point. Well, it's always going to point back to the sun. And then you can just calculate the strength of it right there. All right? When a satellite is orbiting a circular orbit, what is the centripetal force? It says up there, but just think about it. What force could possibly act on a satellite to keep it in a circular motion around a planet?
That's gravity.
Gravity. It's outer space. There's no friction. Nothing's touching it. There's no applied force. There's no electromagnetic. Gravity is the only force that acts. So gravity is your centripetal force. The Earth is constantly pulling the satellite towards itself. Well, that's what keeps it in a circle. You also remember the fundamental forces, right? The basic forces of the entire universe. Gravity is one of them. Electromagnetic, right? Opposite charges attracting each other. That is a fundamental force. You remember the other two? They're really obscure. You don't really need to know them.
It's almost like the atoms, right?
Yeah, there's the strong nuclear force and weak nuclear force. I don't really know what the weak nuclear force is. The strong nuclear force, I know, is what holds the nucleus of an atom together. Right? You got protons and neutrons in the middle of an atom. There's a strong nuclear force that keeps them together.
Maybe
It's incredibly strong, but it also has a very short range.
maybe it's the force of nuclear electrons.
Yeah, it actually gets into like subatomic particles like quarks, leptons. It gets really complicated.
Leprechauns do work.
Is gravity the strongest or weakest of all the fundamental forces in the universe? Weakest. It's actually pathetically weak. Right?
They're weak.
Remember my example? Gravity's trying to pull me to the center of the Earth. What's stopping it?
One of the other forces.
The electromagnetic force. Easy. Right? All day long, the electromagnetic force opposes gravity like it's nobody's business. Yeah. Gravity is actually very weak compared to the other forces. Now, we feel it the most. We experience it the most because it acts on the biggest scale of masses. The nuclear forces are subatomic. Electromagnetic force, you got to get really close. But, I mean, think how massive the Earth is. Well, no wonder gravity's strong. Because the Earth has an absurd amount of mass. But it takes all that mass just to keep you on Earth. Right? Okay, so I want to give you guys the test now. I want to make sure you guys have enough time. So I need you to get rid of everything. Right? Computers away, notebooks away, binders, something. Just get them away. Right? Backpacks, if you got them on the ground or whatever, that's great. Just get stuff away. You can have your pencil, your calculator, your AP equation sheet, and then the test. Brody. Yes, you can use them. Okay. Has everyone got that? What?
I know, you said the other guy. Sorry. You said that. The other guy's also black.
Yeah, I might have to go get some for you. All right, you guys, I need to give you enough time to do this, so I'm going to pass the test out. Make sure to get your names on it. 20 questions. Make sure to keep everything away. If you have questions, let me know. Right? Raise your hand and let me know. You're welcome.
This is bad, right? Say this is always okay.
Yes. Yes, you can use your calculator, you can use your AP equation sheet, and a pencil. That's it. Take your test.
Email address?
You want our email address or
Or
name?
name for, because these are.
You guys are smart kids. You're an AP class. This is a Google form that I printed, so that everyone's got the same thing. You can if you want.
I'll put both.
Good night, you guys. All right, focus up. If you have any questions, let me know.
Mother's made
Get started. I'll get you a calculator.
Credit card number.